Hello friends, I'm Bob. In this video I will be showing you the solution to the integration of square root of 1 plus 1 over x dx. But before I do so, if you guys like the solution, press the thumbs up icon below this video. The first step we're going to do is we are going to combine into one fraction. We get the following: the integral of square root x plus 1 over x dx. And then I split the setup into the following. We numerator have square root of x plus 1, and then our denominator will be square root of x dx. After which we'll apply the technique called the integration by substitution. We substitute our square root of x to be u, in which my x will be equals to u squared, and then my x plus 1 is equals to u squared plus 1. Then we differentiate x with respect to u. This gives us 2u, in which multiplying both sides by du, I get dx is equals to 2u du. And now we can apply the integration by substitution to express in terms of u. I get the following: my numerator would be the square root of x plus 1. So this is equals to the square root of u plus 1. And then my denominator, I get u. Dx becomes 2u du. The next step I will do is I will cancel the u and bring the constant 2 out of the integral side. I get the following. And then next step what I will do is apply the integration by substitution technique. For this particular case, I let my u be equals to tangent y, in which I take u with respect to y, I get secant square y. Multiplying both sides by dy, I get du is equals to secant square y dy. And now I can further transform it into expressing the solution in terms of y. I get the following: my u becomes tangent y. So this is tangent square y because it's u squared plus 1, and then I have my du here, which is secant square y dy. Based on the trigonometry identity of tangent square y plus 1, this gives us secant square y, and then I have secant square y dy. I further simplify it and becomes the integral of secant y, secant square y dy. Next, I apply the integration by parts technique. The integration by parts technique tells us that if I were to define a term as u and define another term as dv, so this is equals to uv subtracting away the integral of v du, in which to find my v I will integrate the term dv, and to find my du I differentiate the term u. So for this case I will let u be equals to secant y, and then my dv to be secant square y dy. To find my du I differentiate u with respect to dy, so this gives me secant y tangent y, in which multiplying both sides by dy, I get du is equals to secant y tangent y dy. Whereas to find my v, I will integrate dv, which is the integral of secant square y dy. This gives us tangent y. Once I found my du, u, dv, and v, I can apply the integration by parts formula to move on to the next step. I get the following: 2 times u, which is secant y, v is tangent y, subtracting away the integral of v, which is tangent y du, is secant y tangent y dy. And we know that tangent times tangent gives us tangent square y, and then based on the trigonometry identity, tangent square y is equals to secant square y, subtracting away 1, secant y dy. We further simplify into the following. It becomes the integral of secant cube y plus the integral of secant y dy. From here we know that this particular equation and this particular equation down here, they are equal. So hence we can further simplify the equation into the following. We are actually finding the integral of secant cube y. So this is equals to secant y tangent y, subtracting away the integral of secant cube y plus the integral of secant y dy. So this equation, basically I can add both sides by the integral of secant cube y. So I get 2 times the integral of secant cube y. This is equals to secant y tangent y plus the integral of secant y dy. We next evaluate what is my integral of secant y. The integral of secant y basically is just equals to ln the absolute of secant y plus tangent y plus c. So my 2 times of integral of secant cube y is equals to secant y tangent y plus ln absolute secant y plus tangent y plus c. From here now we need to transform back to expressing in terms of x because the question expresses in terms of x. How do we go about doing it? We know that we make substitutions by converting square root of x to become u, and then from u to become secant y. So hence secant y is 1 over cosine y. This gives me square root of x. Therefore cosine y is basically just 1 over square root of x. I draw this particular triangle just to make things a little bit clearer. I have an angle y in which my adjacent is of length 1, my hypotenuse is of length square root of x. Hence basically my opposite angle is just square root of x minus 1. So basically I can use this triangle to convert expressing y to expressing in terms of x. Hence the answer is as follows. My secant y is just square root of x. My tangent y is basically sine y over cosine y, in which my sine y is opposite over hypotenuse. We have square root of x minus 1 over square root of x. And then my cosine y is adjacent over hypotenuse. So that will be 1 over the square root of x plus the ln of, same thing, secant y is square root of x plus tangent y is square root of x minus 1 over square root of x over 1 over square root of x. Hence simplifying the whole solution, I get the square root of x times square root of x minus 1 plus the ln of square root of x plus the square root of x minus 1. And this is the final answer to the integral of square root 1 plus 1 over x dx. If you guys like the solution, help me press the thumbs up icon and do consider to subscribe for more integration problems. I'm Bob, thank you guys for your support, and I will see you in the next video. Goodbye guys.